We will now demonstrate multi-load in ParetoWorks using GEGrab example. If you have not watched the knuckle multi-load video, please do so. The GEGrab problem has 4 different loads with a yield strength of 131 ksi. To solve this problem using ParetoWorks, first the part is initialized with English units. Observe that there are 3 bodies. For the main body to be optimized, we pick the material and click Apply. For the other 2 bodies, we pick the same material but choose the option of Do Not Optimize. In other words, we do not want to remove material from these 2 bodies. Next, we apply the boundary conditions. Select the 4 sets of faces and restrain them in all directions using the fixed boundary condition. The first load is a vertical force of 8,000 pounds total. To simulate this load, we select the first face and apply a 4,000 pound along Z. The same force is applied on the second face. The second load is horizontal force of 8,500 pounds total. Increase the load set. We select the first face and apply 4,250 pounds along X. The same force is applied on the second face. The third load is 9,500 pound force total at an angle of 42 degrees to vertical. Increment the load set to 2. And apply the X and Z components for the 2 faces. The final load is a torque of 5,000 pound-inches. The distance between the center of the 2 faces is 1.125 inches. We apply the appropriate forces on the 2 faces to simulate that torque. One can now cycle through the boundary conditions. For FEA, we can select the first load set and perform FEA with 100,000 elements. Observe that the stresses are around 58 kSI. We can repeat the FEA for the second load set. The other two load sets can also be analyzed. We can now proceed to optimize the topology. If you have not watched the knuckle multi-load video, please do so to see how to optimize for each load. Here we will optimize for all loads simultaneously. Observe, the optimization stops at a volume fraction of 23.5. One can study the topologies for all other volume fractions. To further analyze the results, you can also study the FEA results. For one of the loads, the stress reaches the limit of 131 kSI.